In the 20th century, the modern developments in science allowed the human race to build rockets and artificial satellites. While the major world powers competed in the space race for other purposes, Dr. Vikram Sarabhai in early 60s laid the blueprint of Indian space program, which was different and focused mainly on the use of space technology for benefit of the common man. With his vision firmly in place, Sarabhai established the Physical Research Laboratory on 11th November 1947 in Ahmedabad. The Indian space journey can be said to have begun on 21st November 1963, when the first sounding rocket, Nike Apache, was launched from Tumba Equatorial Rocket Launching Station, Turles, near Thiruvananthapuram, Kerala. The first step towards formalization of Indian space program were taken when government formed Indian National Committee for Space Research, INCOSPAR, in 1962. This committee was chaired by Dr. Sarabhai and was formed under the Department of Atomic Energy. In 1965, Space Science and Technology Centre SSTC was established at Veli near Tumba for developing technology for rockets and satellites. India's first indigenous sounding rocket Rohini 75 was launched on 20th November 1967 from Tumba. Also in 1967, the first experimental satellite communication Earth station ESCES was set up and operationalized in Ahmedabad. Indian Space Research Organisation was established on August 15, 1969 with Dr. Sarabhai as its first chairman. While the development of the required technologies was started and continued in India, a suitable location for eastward launching of the rockets was needed. Dr. Sarabhai's team zeroed in on a pear-shaped Sriharikota island in Andhra Pradesh. With Bay of Bengal on one side and Pulicat Lake on the other, it was found suitable for geosynchronous and the polar satellite missions. This location, popularly called Sriharikota Range, SHAR, was developed and operationalized in October 1971 as a space port for Indian space programs. It is today regarded as the world's second best location for launching space missions. Year 1972 saw the birth of many new establishments of ISRO. SSTC at Thiruvananthapuram was renamed as Vikram Sarabhai Space Centre, lead centre of ISRO for launch vehicle design and development. It provides the technology base for indigenous satellite launch vehicles development programs. The same year, Space Applications Centre SAC was formed at Ahmedabad. The centre designs and realizes all the payloads of our satellites and their applications for national development and societal benefits. UR Rao Satellite Centre URSC Bengaluru, formerly known as ISRO Satellite Centre ISAC, was also formed in 1972. It is today the lead centre for building satellites and developing associated satellite technologies. The centre also pursues advanced technologies for future missions. The Department of Space DOS and the Space Commission were also set up in 1972. The main function of Space Commission is to frame and approve policies which are implemented through DOS. ISRO was formalized as the executive agency of the DOS. The administrative headquarters of ISRO was established at Bengaluru. The dream project of Dr. Vikram Sarabhai, SITE, was launched in August 1975 and continued for 1 year. In this, television in India entered the life of the rural population of 2,400 villages spanning 6 states. Developmental TV programs were made and transmitted from the Ahmedabad Satellite Earth Station and broadcast through the American ATS-6 satellite. KEDA Communications Project, KCP, started in 1975, worked as a field laboratory for need-based and locale-specific program transmission in the KEDA district of Gujarat. Satellite Telecommunication Experiments Project, STEP, initiated in 1977, was aimed to test possible use of a geosynchronous satellite for domestic telecommunication. The sight and step experiments were the stepping stones towards the conceptualization of Indian National Satellite System INSAT. In 1981, an experimental communication satellite, Apple, was built indigenously and launched from European Space Agency's Ariane rocket. The INSAT system was then conceived. First 4 of INSAT series satellites were built by Ford Aerospace of USA. Subsequently, ISRO developed the capability of building communication satellites indigenously, and in 1992, the first indigenously built communication satellite, INSAT-2A, was launched. This was followed by 4 other satellites. Teleeducation and telemedicine are 2 flagship societal applications started by ISRO to bridge the digital divide in the society in education and health sectors. Many other applications and needs are today supported through these communication satellites. Today, India has the largest domestic fleet of advanced communication satellites, which also includes the latest and modern high-throughput spot beam satellites like GSAT-11, GSAT-19 and GSAT-29. A major milestone in the journey of Indian space program was achieved in 1980 with the first successful flight of indigenous launch vehicle SLV-3, having a capability to place 40 kilograms payload into the low Earth orbit. 1980 also saw formation of Liquid Propulsion Systems Centre in Bengaluru. LPSC is today a major centre for development of liquid propulsion technology. Development of Vikram Sarabhai Vikas liquid fuel engine was successfully developed by ISRO in 1988. Since then, it is a vital component of all launch vehicles. The first successful flight of Augmented Satellite Launch Vehicle ASLV in 1992 paved the way for learning many new nuances of launch vehicle design for complex missions. This path led to realization of workhorse, ever-reliable launch vehicle, the Polar Satellite Launch Vehicle PSLV in 1994, when it successfully placed IRS-P2 in orbit. PSLV was also instrumental in launching landmark missions like Chandrayaan-1, the Mars Orbiter mission, and has also created world record of launching 104 satellites in one mission. As a result of focused efforts, ISRO succeeded in developing C-12 cryogenic upper stage, and the first successful flight of GSLV Mark II with indigenous cryogenic stage took place in January 2014 when GSLV D5 launched GSAT-14 satellite. GSLV is now an operational vehicle capable of launching 2-ton class of satellites into geostationary transfer orbit. GSLV Mark III D1, the first development flight of GSLV Mark III with indigenous C-25 cryogenic upper stage, took place in June 2017. The vehicle launched 3,136 kg GSAT-19 spacecraft successfully to GTO. Launched successfully on 22nd October 2008, the grand success of India's first lunar mission Chandrayaan-1 caught the attention worldwide, and we began to be counted as a major player in space exploration. The spectacular success of our first interplanetary mission Mangalyaan in 2013 placed the country on a pedestal which is shared by only few nations. For the first time, a nation succeeded in a Mars mission in the very first attempt.
मंगल को मॉम मिल गई.
The heavy-lift GSLV Mark III is instrumental in launching landmark missions like Chandrayaan-2.
Chandrayaan-2 is the next leap in technology as we attempt to soft land close to South Pole of Moon. And the next mission what we are going to have is the L1 mission. It is going to have a mission to Sun to study the corona of sun, and the next mission what we are going to have is the mission to Venus.
With the successes of its launching systems, its satellites, together with its space exploration missions, ISRO was well poised to conquer the next frontier of human space flight. Team ISRO is confident and raring to meet this challenge as desired by the nation through a successful human spaceflight mission, Gaganyaan.